Hi there, this is Miss Townsend and welcome to Math with Townsend. We're looking at the Grade 9 Academic Analytic Geometry Summative. This is question 12. So question 12 says, Philip has a phone plan that costs him money each month depending on how many minutes he uses his phone. The formula for determining his monthly phone costs on his current plan is right here. And then there's A, B, C parts to this question. But before we look at A, B, and C, let's make sure we really truly understand what this formula is telling us. So we know that C represents the monthly phone bill costs. And what I hope that you notice, this is your brain. What I hope your brain tells you when you look at that equation is that it's an equation in the same form as y equals mx plus b. You have a dependent variable here because cost depends on number of minutes. So here's your independent variable, time, in minutes. So that means this must be slope, and this must be the starting value. So what does that mean about his phone bill? So we know that his starting value, or probably more appropriate in this case to say his flat fee, is $15. So no matter what, every month he has to pay a minimum of $15, even if he uses 0 minutes on his phone bill. That's for administrative costs, whatever. And then 0.05, that must mean that he pays 5 cents per minute that he uses his phone. That's what it means. Now we're supposed to write an equation where cost is always cheaper. So you know me, I like to have a visual going on for me to really understand a word question. So I sort of started this visual while you were away. So I know that the phone plan starts at $15. So along the vertical or dependent axis, I've put a dot at 15 because if he uses 0 minutes, it costs him $15. I wanted to think with you, however, about the horizontal axis. Does it make sense for me to label this as 1 minute, 2 minutes, 3 minutes? The problem is 1 minute would represent $15.05. 2 minutes is $15.10, and so on. And that's a really, really tiny little rise on the graph. And it's not really going to show me a really realistic view of what's going on with this phone plan. I mean, really, 1 minute, 2 minutes, come on. It makes more sense to use numbers that are realistic and larger and then involve, some sort of visible growth on this graph. So I'm going to talk about maybe 50 minutes and 100 minutes and 150 minutes. That makes more sense to me and is more reasonable to this question. Like if someone uses 50 minutes worth of phone time, 50 minutes at 5 cents a minute would be $2.50. So that's a total of 15 plus 250. So that would be $17.50 a month. And then 100 minutes, 100 times 5 cents, $5. $5 plus the $15, so that's at 20. And you start to get an idea about what this graph looks like. And in fact, I cheated a little and I used technology. There's an actual lovely version of this graph. And you'll notice again, 100 minutes is a $5 charge for the minutes. And $5 plus $15, you can see that there's a point right here at 20, right? And $50 was $17.50, and you can see that that's where that is. So it's the same graph, it's just this one's a little nicer to work with. So now we can start to look at question A. We need a graph, an equation, a line that is always cheaper. So let's go to this graph and start to play around. Let's draw some. Now, if it's always cheaper, then clearly my graph has to start below 15. I would not try to get into negatives because that seems like you don't get the question if you try negative numbers. Because really, what phone bill is negative? It doesn't make sense. So start with any number between 0 and $14.99. Let's say 10. Now, when I draw my line, now I'm going to think about slope. Can I have the same slope? Would that green line always be cheaper? Yeah, that green line's definitely always going to be cheaper. You can see that it's never going to intersect or cross over. So the green is always cheaper. So you can have the same slope. Could I have a smaller slope, meaning a less steep line? Sure. That's definitely never going to cross it. Could I have a slope of 0? Yeah. So a slope of 0 would represent a phone company that charges a flat rate and doesn't care how many minutes you use. And as long as, again, it starts off less than 15, that would certainly satisfy the conditions. Could I have a negative slope? Well, to be honest with you, that doesn't make any sense. A negative slope would mean that the more minutes you use, then the less it costs per minute. And theoretically, if you used a lot of minutes, the phone company would pay you. Well, it sounds nice, but it's never going to happen. And if you tried to do something like that, you would make someone think you don't get the question. So again, our slope has to be between 0 and here's parallel. Could I have a slope steeper than my line, like this? Well, on this graph, it certainly looks fine, but realistically, if I continued this graph, if I could draw these lines longer, you'd see that eventually that green line would intersect the black line. And as soon as they intersect, this green line represents a more expensive plan for these times down here. So you can't have a slope greater than the slope that was given to you originally. So let's summarize. If I want to create an equation that is always cheaper than this equation, we decided that you have to start somewhere between 0 to 14,999,999,999,999. You get the idea. So in other words, you have to start somewhere less than 15. And again, don't go into negatives. It doesn't make sense. And we decided that the slope had to be parallel, was fine. So same slope. That was okay. We could have less slope, or we could have a 0 slope. As long as this was true, then I could have parallel slope, a smaller slope, or a 0 slope. So here's some examples of equations that you could write. You could simply say that cost equals 10. Simple. It's a flat rate phone bill. Doesn't matter how many minutes. It's 10 bucks and it's always cheaper. Or you could say 0.05 t plus 10. So this one's parallel, but it's always going to be lower. Or you could say 0.04 t plus, let's go 8 this time. So this is less and the slope is less. There are some examples. Again, you could do anything. Next question is now we're always more expensive. So if I want to be always more expensive, obviously, first of all, I have to start above 15 because I have to start more expensive if I'm always more expensive. So if I start above 15, there's my parallel line. Will that work? Yeah, this parallel line will always be more expensive. Steeper line? Yep, definitely I can make a steeper line. It will never go down and be less expensive. Could I make a less steep line? Well, the same problem as before. It may not look like it on this graph, but these lines theoretically continue forever. And at some point, if that green line is less steep than the black line, they are going to, they're going to do this. They're going to cross over. And as soon as they cross over, the black line becomes more expensive. And we wanted the green line to be always more expensive. So it has to start at a higher starting value, and it has to have a slope equal to or greater than the other slope. So what are some examples? So I can have an equal slope to the original slope as long as I start higher. So there you go. I could have a greater slope, but I still have to start higher. So there are some examples. Again, this number here has to be greater than 15, and my slope has to be 0.05 or more. And any equation you write like that is a good answer. Just try to keep your numbers reasonable. Don't play games that suggest you don't understand what's happening. Finally, question C. We need to write an equation that's cheaper if less than 100 minutes are used, but more expensive if more than 100 minutes are used. So here's that 100-minute mark. Obviously, it's important, and we'll read our graph. It's 100 minutes and it's 20 bucks. So that's obviously important to this question. And I want to be cheaper. So when I use any of these times down here, up to 99 minutes, I want to be less than this line. And when I go above 100, I want to be more than this line. So just by doing that, you can get an idea about what sort of, how this line might look. So let me grab a line and try to fit one into this particular parameter. So I know that I need to be less expensive. So I could start at 0. I could start anywhere in here. All right, let's start at 0. Oops, that's not a line. So if I start at 0, I'm definitely cheaper. Now, at that 100 point, 120 mark, I have to cross over from being cheaper to being more expensive. So there is an example of a line. Certainly, again, it's not the only one. I could have started at 5 minutes and drawn a line like this. I could start at $10 and draw a line like this. I could start anywhere down here. And as long as I pass through this point, I'm going to have a good line. So what do we know about this line we have to create? We know 3 things. We know, first of all, it has to pass through the point 120. So that's time and cost. We also know that it has to start below 15. And what do we know about the slope? Well, look at the slope of these 3 colored lines. Look at their steepness compared to the steepness of the black line. They're all steeper lines. So the slope, slope does not have a T right there. Slope has to be more than 0.05. All 3 of these things must be true. So let's create an equation. Let's pick a slope of 10 cents a minute. Now, I can't pick a starting value if I've picked a slope, because it's not just 2 of these that must be true. They all have to be true. So that point where t is 100 and c is 20 has to be on this line. So I'm going to do a substitution using that one point that I know for sure. And that will tell me what starting value must belong to this slope. So 10 cents times 100 is 10 bucks. So B equals 10. So there's one potential equation. And again, you can't just randomly pick both slope and starting value, because you have to ensure that you go through the right point. This time, I'm going to give you another equation. But this time, let's say I don't know the slope and pick a starting value. How about $5? So this time there's a starting value of $5, and we want to find slope. So again, we know that at t equals 100, I have to go through 20. So do that substitution, and then solve for your missing variable. So I'm going to subtract 5, divide both sides by 100. So I get a slope of 15 cents. So 15 cents, per minute, $5 flat rate. So you can see that, again, you do have choice. You can pick any starting value you want between 0 and 15 and calculate slope. Or you could pick any slope you want greater than 5 cents and calculate starting value. Okay, so that's it. That's question number 12. Whew, almost 15 minutes, which is YouTube maximum. I hope that helped. Again, ask me in class if you have questions. That's all.